Hi, everybody. I'm Vinay Vishwambharan. I'm a principal product manager at Esri. My focus is primarily imagery and geospatial AI.
Hi everyone, I'm Gaby Gutierrez. I'm a solution engineer at Esri for our national government team.
All right. Time and time again, you've heard me say imagery is key to any geospatial workflow. Integrating imagery, both commercially available imagery and freely accessible imagery, with powerful geospatial AI capabilities and spatial analysis capabilities in ArcGIS unlocks a whole new set of capabilities. GeoAI or geospatial AI accelerates traditionally manual tasks, such as object detection in defense and intelligence agencies by automating the identification and the classification processes. So today, Gabby is going to show you how GeoAI automates aircraft detection and classification, streamlining analysis, and enabling informed decision making at scale. So, Gabby, you want to give a little bit of context before diving into your demonstration?
Sure thing. So today we're going to see how we can use ArcGIS as a complete AI system by looking at an object detection workflow. So like Vinay said, this workflow is commonly done in defense and intel spaces where analysts take imagery and identify and classify objects by hand. So using ArcGIS, not only can we use GeoAI to speed up this process, but we can scale it to any location and automate it too. In this demonstration, we'll use GeoAI to generate aircraft detections for the entire state of California and use configurable applications like an ArcGIS dashboard to review our results and investigate any anomalies we find. This is just one example of how we can leverage ArcGIS and use it as a complete AI system. So let's take a look at how we accomplish this.
Today, imagery has become a readily available asset, and when partnered with ArcGIS and its computer vision capabilities, we have the power to transform pixels into valuable insights and unlock a new era of understanding. One example is the use of Esri's deep learning tools, like this one, that'll spatially detect objects based on the model we specify. Esri's Living Atlas provides over 70 pre-trained models from things like building footprint extraction to land cover classification that we can pair with deep learning tools to aid in imagery exploitation. These models can be pulled into your organization and used on your network as well. Today, I'm going to use Esri's TechSAM model, an open source vision language model. We've taken Meta's Segment Anything and enhanced it with generative AI. Using natural language text prompts, we can extract specific objects from our imagery, like red cars, trees, or in this case, aircraft detections. Looking at the output from this tool, the model was successfully able to detect any aircraft and mask them out within my area of interest. I wanted to know more about the type of aircraft that was detected and monitor their activity. So using ArcGIS Deep Learning Studio, I created a model of my own that would not only detect the objects, but classify them too. I scaled my analysis over the entire state of California daily. Applying deep learning across the entire state, I knew the most probable aircraft detections would be at airports. So I created geofences around airports to monitor their activity and allow me to investigate any detections outside of a known area. With this daily analysis, I was able to build statistics and understand what the average count for each airport looked like. Each detection has also been enriched with the associated airport it resides in addition to the plane classification and confidence score provided by our model. Although we could run this analysis manually, we instead used an ArcGIS notebook to automate the inferencing and analysis for each day. The notebook runs the Detect Objects tool against the imagery that day, does any spatial analytics, then updates our airport and detection layer with supporting attributes and statistics gathered from our analysis. Let's finish running the notebook for our current day of detections. Because of the scale of our analysis, we wanted to be alerted when there were any major changes in the number of detections at each airport or the number outside of any known areas. So we configured a webhook to monitor these changes and alert us in the form of an email. Selecting the link provided will open us to an ArcGIS dashboard. From this dashboard, we can get a quick glance of our detections for the day and their classification, as well as review any anomalies found within those results. Since we're here, let's take a look at San Diego. Selecting the feature not in an airport and investigating further, we come to realize that it is in fact not a plane, but a boat near the marina. Looking at the confidence score from our model, it has a 35% confidence rating, meaning that the model wasn't so sure that this object was in fact a plane. AI is not always going to be perfect, but with human-machine teaming, we can carry out quality checks and further improve our custom models to get as close to perfection as possible. We can elevate how we visualize patterns from our detection over space and time by viewing them collectively in a voxel layer. This enables us to visualize a week's worth of detections, with the ground level being our first day and the surface of the voxel our current day, enabling us to understand any anomalies or hotspots from our detections over time. By integrating automation and rich analytics with ArcGIS, we can streamline our ability to extract insights across any geographic area for any object. This, partnered with a collaborative approach between AI and human-machine teaming, ensures continuous improvement and reliability in our spatial intelligence, overall enhancing our capability to analyze and understand valuable assets at any scale. Thank you.